Okay, so let's discuss the intermolecular forces of attraction. No? Basically, the topic about gases, solids, and liquids, and how do they come up as is. No? Bakit kaya sila naging ganon? No? So, i-answer natin yon in this chapter. Okay, so let's go first with the concept of phases. No? So, phases of matter. So, ano yung phases of matter natin? What is the phase first? No? So, when you say phase, that is a homogeneous part of the system in contact with the other. No? So, that is separated by a boundary. So, in short, yun yung itsura ng matter as a whole. No? So, yun lang yung kwento niyan. So, for example, we have here the glaciers. No? So, we can observe two phases in there. No? The solid ice, no? And the liquid water. No? So, dalawang phase yan. Okay? In general, we have three states of matter, no? Which are the gas, solid, and the liquid phase of matter. Okay? So, let's check on their characteristics. No? So, when you say gas, no? Its volume, no? It occupies the volume of its container. No? For example, you have a bottle. No? So, yung gas doon, ang i-occupy niyang space is lahat. No? It will occupy all the sides, all the space available inside the bottle. No? So, yeah. So, when it comes to volume and shape, no? Gases occupies the volume and the shape of its container. No? Its density is low because the matter is spread out in the entirety of the volume. No? So, kalat yung matter sa volume. And remember, density is mass over volume. So, if your volume is big, no? For example, isang room yan. So, yung volume na malaki, that will give you small density. No? Kasi inverse yung relationship ng density with the volume. No? Given by the equation. No? Sulat ko ulit. Okay. So, inverse ang relationship ni density and volume. So, paano mo malalaman kapag inverse? Nasa numerator yung isa, nasa denominator yung isa. So, that means if gases occupy big volumes, that means it must have low density. No? Then, let's get to its compressibility naman. So, when you say compressibility, that is how you compact the matter. No? Kung pwede ba sila ipitin. No? So, for gases, that is very compressible. No? For example, itong inuupuan kong chair, may gas cylinder dito. No? Kapag pinindot ko, yun, mako-compress yung gases sa ilalim ko. No? So, yun lang. So, yung mga computer chairs natin. So, yun, may gas cylinder doon that when you press the nozzle, no? I mean, when you press the knob, maiipit lahat ng gases. So, bababa yung pagkaupo mo, no? So, yun. So, gases are very compressible, no? Yun. So, pwede mo sila ipit-ipitin, no? For example, you have, ano pa ba yung mga gas na compressible? Yung sa gulong, no? Sa gulong ng car nyo. So, yun. Yung gases doon, ipit-ipit yung molecules. That's why matigas yung car, no? Okay. So when it comes to the motion of the gas molecules naman, they are very free, no? So they are freely flowing. They will go everywhere they want, no? And they will diffuse out, no? For example, um, yung bagong luto na food, no? So kunwari, galing yun sa kitchen, aamoy nyo siya sa bedroom nyo, no? So yun, because gas molecules are spreading all over the place, no? Kasi yun yung kanyang tendency, no? It has a tendency to occupy the entirety of the volume. That's why kumakalat yung gases, no? Kumakalat yung smell, no? So yung very free in motion din kasi ang molecules niya. So now let's go with liquids, no? So for liquids naman, it has a definite volume, no? Ibig sabihin, fix yung volume niya and it assumes the shape of the container. So yung liquids, unlike gases na kinukuha niya lahat ng volume, yung liquid, fix lang yung volume niya. No? So fix yung volume niya depending on the number of liquid molecules. No? For example, yung water molecule ng water na 1 liter. So yung volume na yon is fixed yon. No? Nagbabago lang yung itsura because you place them into different containers. No? So, kunwari, yung liquid na 1 liter, ilagay mo sa drum. So, it will appear na onti lang siya. No? Pero ilagay mo yan sa baso, so sobra yun, no? So yun. For liquids, the density is high because the volume is fixed and the mass is fixed, no? So fixed yung dalawang term na yan, and hindi naman nag-spread out yung liquid, no? All over the place, no? So unlike gases, liquids have high density, no? Compressibility of liquids, only slightly compressible. Onti lang yung pwedeng mo makompress dyan. For example, yung mga sa roller coaster, they are powered kasi with hydraulics, no? Yung hydraulic cylinder doon, may liquid yun na kinocompress in order to lock the position ng safety vest, no? Doon sa mga roller coaster, no? Yung nakatakip sa inyo. So yun, may liquid na compressed lang doon that when it is compressed, it will lock you, no? So parang hindi ka mahulog. So yun, they're slightly compressible, no? Although compared to gases, mababa lang yung compressibility niya talaga, no? Okay, so again, saan natin makikita yung compressibility of liquids? Sa hydraulics, no? So yun, in hydraulic powered devices, no, such as roller coasters, no, even sa car, no, may mga hydraulic cylinder doon na may liquids din, no. Okay, so how about the motion of molecules, no? If gases are freely flowing, ang liquids naman daw, they will slide past one another. So dadaloy-daloy lang sila, no? Magro-roll-roll lang yung ating liquid molecules, no? So hindi sila kakaalat, no? Pero gugulong lang sila sa isa't isa, no? So imagine that as, let's say, isang stack of kalamansi na nahulog, I mean, nabutas yung ng kalamansi, yung container. So, ano mangyayari doon? Di ba, mag-flow lang yung mga kalamansi particles to one another. So, parang ganun lang yung idea with liquids, no? So, yan. So, instead of scattering all around, sila ay dumadaloy lang sa isa't isa, no? Pumapatong-patong lang sila sa isa't isa as they spread out, no? Okay. So for solids naman, this has a definite volume and shape. Fixed yan kahit ano mangyari. Okay. So because the volume and shape, no, is fixed, the density is also high, no. So hindi magbabago yung density niya, technically, no. And they are virtually incompressible. So hindi mo na sila may ipit because solids are already compact, no. Yung kanilang matter ay dikit-dikit na. So you cannot compress them any longer kasi compressed na sila. Okay, so that's why they have they are incompressible at all. How about the motion of molecules? So for example, yan, may nagtutok-tok sa taas ko. So yan. So the motion of molecules is through vibration. So nagva-vibrate yung molecules. That's why yung nangyayari sa kabila is mararamdaman mo sa kabilang side din ng solid. No? For example, yun nga, may nagpupukpok sa taas ko. So, nafe-feel ko yung vibration ng molecules, so I can hear it. No? So, ganun lang yung idea for solids. Okay? So, let's wrap it up. So, for the states of matter, we have 3 states of matter: gas, liquid, and solid. Okay? So, in terms of the volume, gases and liquid, they have certain volume, but they occupy the shape of the container. For density naman, they are in contrast. Gases have low density because they tend to spread out, no, in the entirety of the volume, no. Okay, compared that to liquid na fixed na yung kanyang volume, so its density is high na already. For compressibility naman, gases are compressible kasi they spread out. That means pwede mo sila ipitin pa ulit, no? Pabalik, no? So however, for liquids, they are not that spread out, no? So you can just compress them slightly, no? So unti lang yung compression na pwede mo gawin, no? Okay, then for the motion of molecules, gases tends to spread out freely, no? And for liquids, they will just slide from one molecule to another, no? So papatong-patong lang sila sa isa't isa. Then for solids, ito, fixed ang volume and shape. That means high ang density and incompressible siya. So, kumbaga yung matter niya is dikit-dikit na talaga and you cannot compress that any longer. And the motion of molecules would be vibration na lang, no? So, limited yung galaw nila. Okay? So ngayon, ano kaya yung reason why we have solids, liquids, and gases? Bakit kaya meron tayo niyan? No? The answer would be the intermolecular forces of attraction. No? So ito kasi yung dahilan kung bakit may solids, liquids, and gases tayo. It has something to do with the compressibility or the distance of one molecule to another. Kasi ganito lang yung nangyayari. Why we have three states of matter. If ang matter nyo, magkakadikit yan. For example, itong aking mga fist, no? Kung magkadikit yan, they will make up solid particles, no? Pero kapag pinaghiwalay mo onti yan, magiging liquid yan. Then, paghiwalay mo pa yan lalo, magiging gas yan. So virtually, yung ating phase of matter, you have the same molecules wherein the distance changes lang, no? So pag masyado silang madikit, they will create solid particles. Pag medyo magkahiwalay, liquid yan. Pag pinaghiwalay mo yan na matindi, gases yan, no? Okay? So the reason why we have solids, liquids, and gases is because of the distances of molecule, no? So the distances of molecule depends on the intermolecular forces of attraction. So the more they are attracted to one another, the closer they will be. Hence, they will be more solids, no? Okay. So, yan. So intermolecular forces are attractive forces between molecules, no? Compare that to the intramolecular forces, no? Teka lang, lobat. So pag sinabi naman nating intramolecular forces, intra, no? Parang intramuros 'yan, no? Intramuros is in Spanish ay within the walls, no? Ito naman within the molecule, no? So when we say within the molecule, these are the chemical bonds, no? So itong intramolecular forces, chemical bonds 'yan. For intermolecular forces, these are attraction between molecules, no? Kung gaano ka-attracted yung isang molecule sa kabilang molecule, no? Okay, so yun lang. Skip natin yung ibang part dito. Okay, so yan. So generally, intermolecular forces are weaker than intramolecular forces na. Kasi ganito lang yung idea dyan na yung molecules, madali sila paghiwalayin. Pero yung particles na nasa loob ng molecule, mahirap sila paghiwa-hiwalayin din. No? Okay, ganito lang yung idea niya. No? Kunwari, may dalawang magjowa. Di ba, madali lang ipag-break sila. No? Pero kung kunwari, yung isang tao, ano mo siya, ah, ano gagawin mo sa isang tao? Kunwari, tatanggalan mo siya ng kuko. Medyo mahirap gawin yan, na? Kasi nakakabit na sa kanya yung kuko niya. Okay? So, unlike sa jowa niya, nakahiwalay sila. Pwede mo sila paghiwalayan, no? So, yun lang yung concept nitong statement na to, that intermolecular forces are much weaker than intramolecular forces. Kasi, hindi naman magkadikit ang intermolecular forces na. Magkatabi lang, no? Pero hindi magkadikit, no? Unlike for intramolecular forces, nakadikit talaga yung particles sa molecule, no? So, yun. So, mas madali tanggalin yung hindi nakakabit kaysa sa nakakabit. So, yun lang yung idea. So, we have ways of measuring intermolecular force such as boiling point, melting point, the enthalpy of vaporization, enthalpy of fusion, and sublimation. For simplicity, itong dalawa lang yung i-discuss natin, no? The boiling point and the melting point, no? Okay, so the boiling point and melting point of our substances has something to do with intermolecular forces, no? Kung ano yung attraction ng mga molecules sa isa't isa na. Okay, so now let's proceed with the intermolecular forces, no? So let's have the dipole-dipole forces, no? So ano yung dipole? Sabi natin last time, dipole, meron kang dalawang poles, kaya dipole, di ba? Ano yung poles na yon? The positive and the negative end, no, of a molecule, no? So bakit nga pala uli may dipole? Because of the electronegativity differences, di ba? Okay. So because of the electronegativity differences of the atoms in your molecule, the dipole exists, no? So nag-exist yung positive end and yung negative end, no? What happens here kasi is that hindi lang naman isang molecule yung meron ka, no? For example, you have water. Hindi lang naman isang water molecule yung nandyan sa batya, di ba? You have multiple number of, teka lang. you have multiple number of water molecules out there na may dipole din. So what happens is that yung mga dipoles, they are attracted to the positive end and the negative end of one another. Now, for example, ito nakikita natin sa screen. This is one dipole molecule. This is another dipole molecule. This is another dipole molecule. No? So, mapapansin nyo that the orientation of the molecules is like this. No? Yung positive ay nakatutok sa negative. No? And vice versa. For example, ito, positive nakatapat siya sa negative. Negative nakatapat sa positive. Negative nakatapat sa positive. Positive nakatapat sa negative. No? So, ganyan yung orientation na nangyayari sa ating dipole molecules. No? So, ang mga ginagawa nilang interaction ay dipole-dipole kasi yung dipole ay kakabit, no? Didikit sa another dipole. No? So, paano sila nagkakabit uli? Because of the positive and the negative charges. No? Alam natin that positives are attracted to negatives, di ba? That's why there is an attraction between them. No? Yung positive ng isang molecule kakabit sa negative ng isang molecule. Yung negative ng isang molecule tatapat sa positive ng isa pang molecule. No? So that is the dipole-dipole forces lang. No? Okay? So this exists when your molecule is polar, meaning may dipole. No? So yun. So ganito yung orientation nila. They are attracted because of the charges. No? So yun lang. So yun yung first type of intermolecular force, no? The dipole-dipole. Dipole molecule, another dipole molecule. Paano sila nagdudugtong-dugtong? Sa kanilang charges, no? Positive attracted sa negative, negative attracted sa positive. And then they will make long chains of that, no? For example, yung water natin, ganyan yung ginagawa nila, no? Okay. Next one is the ion dipole. Ito naman yung kunwari, naglagay ka ng asin sa water niya. No? So we know asin is NaCl that's composed of Na plus and Cl minus. No? So what happens there is that your ions, no, your cation and an ion is also attracted with the dipoles because of their charge. No? Okay. So this is for example, sodium iodide. No? For example, this molecule here is water. Kunwari lang, no? Water na flat, no? So yan, this is water kunwari. What will happen is that the positive ion will be attracted to the negative side of the molecule, no? So kakabit sila kasi alam natin positives are attracted to negatives, no? And yung negative naman, this will be attracted to the positive side of the other molecule, no? Okay, so ganun lang. Ito yung ion dipole forces. Kung kanina, sa dipole-dipole, ang attraction ay between molecules. Sa ion dipole naman, ang attraction is between ions and molecules. No? So this is why your salt dissolves in water. Ganito yung nangyayari. No? So as the salt ionizes, no, nagiging cations and anions sila, yung water molecules will be there to surround the ions. No? So papalibutan nila yung ions, kaya nagiging invisible sila, di ba? So, ganun yung idea. So, yun yung ion dipole interaction. Okay? So, for example, ito. For example, we have sodium cation. This is the interaction with water, no? So, ito lang. Ganito lang yung nangyari. Ito yung H2O. Sulatan ko nga. H2O yan. This red one will be the oxygen. Itong white is itong yung hydrogen. No? So, asan yung negative side ng water molecule? Of course, na kay oxygen. No? Oxygen is partial negative. Hydrogen is partial positive. Bakit negative si oxygen? Because of the electronegativity, di ba? Mataas ang electronegativity of oxygen. That's why it will bear the negative charge. No? So what will happen is that, for example, you have sodium cation here. Di ba positive in charge yan? Tapos yung oxygen ay partial negative. So they will be attracted. No? Same with magnesium, ganun din. So what happens is that when you place your sodium cation in water, it will be surrounded by water molecules in this manner. No? So lahat ng oxygens ay nakapoint kay cation. Okay? So compare that with the anions naman, Ganun din. Baliktad nga lang, no? Yung hydrogens yung nakatapat kay anion. Ganito yung nangyayari sa solutions natin. Okay? So, yun lang. Yun yung dalawang intermolecular forces, dipole-dipole, ion-dipole. Meron pa. Okay. The next one is the dispersion forces. No? Okay. So when we have dispersion forces, this is the attractive forces due to temporary dipoles induced. No? So kumbaga, ang dipole ay sa polar, ang dispersion ay sa non-polar. Okay? So this is shown, no? This is observed, no, for non-polar molecules, no, generally. So yan. So na-exhibit yan ng mga non-polar molecules, no. Bakit? Kasi ang non-polar molecules walang electronegativity difference masyado, 'di ba? So kumbaga yung electrons doon ay nakapabilog lang, no. Kunwari, ito yung molecule natin, CH4. Yung electrons diyan ay nakapalibot lang, no. So non-polar yung CH4 methane, 'di ba? Si carbon and hydrogen, ang electronegativity difference nila ay mababa lang, no. Okay, so that's why they are non-polar. Okay. So, kailan magkakaroon ng dispersion forces, no? Kapag may tumabi sa kanilang ions that can disrupt the balance, no? Kapag may tumabi sa kanilang ions na magde-disrupt ng balance. For example, yung cation. So, anong gagawin ng cation sa iyong non-polar molecule? Remember, yung cation, hihilahin niya yung electrons, no? So, what will happen is that, for example, itong NH4 natin, may tumabi sa kanyang cation. Ang gagawin ng cation na yun ay hihilahin niya yung electrons ng methane mo, ng non-polar molecule mo. So, hihilahin niya yung electrons para mapunta sa side na to, no? So, kukunin niya yung electrons, no? May pool of electrons dito. Okay. So, as that happens, no, yung pool of electrons nangyayari, this becomes now the partial negative side. This side becomes the partial positive side na, no? Okay. So, nandito na kasi mga electrons compared to the other side. So, there is now a dipole. However, this is just temporary. Kunwari, umalis din itong sodium, nawala din yan, babalik uli yan sa normal, no? Okay. So, kumbaga yung dispersion forces, parang infatuation lang yan. No? Pag may dumikit, attracted siya. Pag umalis na, wala na. No? So, ganun lang yung idea ng dispersion forces. No? So, this is just temporary dipole. And that happens when there is a disruption in the balance of electrons. No? So, kapag may gumalaw that is able to move the electrons, then magkakaroon ng dispersion. No? Tapos mawawala uli yon. Tapos babalik ulit. No? Tapos mawawala ulit. So, yun lang yung idea ng dispersion. This is just temporary. You know? This happens when you have molecules that can disrupt the balance. No? So, yun lang. Okay. So, ano pa? Ito naman yung another factor that can contribute to the dispersion forces, the polarizability. No? So when we say polarizability, this is the method of distorting your electron distribution. Ito nga yung sinasabi ko na balance, na yung pagkasira ng balance ng electron. So, kailan mas madali masira yung balance ng electron? Kailan siya mas madaling gawan ng dipole? So, ganito lang, no? The polarizability increases when you have increased number of electrons and more diffused electron cloud, no? So, that means if your nonpolar molecule contains many electrons, no? Ibig sabihin nun, mas maraming pwedeng i-disrupt, no? Hence, there will be more tendency for dipoles to exist, no? Temporarily, no? For example, let's have this trend, no? So, for methane and carbon tetraiodide, no? So, for example, we have this one. Tignan natin yung trend ng melting point, no? Okay, so, ang methane, this is not that polarizable kasi ilan electrons meron dyan. Bilangin natin. So carbon, the atomic number of carbon is 6, so it has 6 electrons, 'di ba? Si hydrogen naman, its atomic number is 1, so it has 1 electron times 4 kasi apat yung carbon yan. So bilangin natin yung electrons na yan. That is 6 plus 1 times 4. May 10 electrons lang kay carbon. Okay, so ibig sabihin yung tendency niya to be polarized, no, para ma-disrupt yung balance is not that much, no. Onti lang kasi yung electron. So since mababa yung tendency niya maging dipole, then its melting point will be very low. Mabilis siya maging gas, no. So mabilis siyang maging gas, no. So yan. Kasi hindi attracted yung molecules to one another, eh. Okay, so yun lang yung idea dyan. Okay, so let's have CH4, no? Carbon tetrafluoride. Okay, so carbon tetrafluoride, ilang electrons meron dyan? Atomic number of carbon is 6, no? So 6 electrons. Atomic number of fluorine is 9. So 9 electrons yon times 4. So ilan yan? 9, 18, 27, 36, 42. 42 electrons ang pwedeng guluhin, no? So since marami tayong electrons na pwede guluhin, then there is more chances of it being dipole than methane. Okay, so mas malaki yung chance niya maging dipole kaysa sa methane kasi mas marami siyang electron, no? Mas marami siyang polarizable parts, no? So as your molecule tends to be more dipole, its melting point will increase, no? Bakit magi-increase, no? Kasi yung tendency of molecules from separating hindi ganun kataas, no? Kasi dikit-dikit sila. Okay, so let's have the last one, carbon iodide. Hanapin ko lang atomic number ng iodine. 53. So this is 6 plus 53 times 4. Ito yung dami ng electron, no? So bilangin natin. That's 53 times 4 plus 6. May 218 kang electron na pwede guluhin na. So since you have many electrons for carbon iodide, no? Carbon tetraiodide na guluhin, so mas malaki yung chance for it to be dipole, no? So ano yung napapansin yung trend, no? The more tendency to be dipole, no? Higher tendency to be dipole, ano nangyayari? Higher ang kanyang melting point, no? So yun. So the more tendency for it to be dipole, it will have higher melting point, no? So one way to check kung mataas ang tendency for the molecule to be dipole is to count the electrons, no? Basically, just count the atomic number and add them up, no? So that is also equivalent to the number of electrons kasi. Okay, so yun. So we started from 10 electrons. Now we have 218 electrons. What happened to the melting point? Mas lalong tumaas, no? Okay, kasi sabi nga natin, the more tendency to be dipole, the higher the melting point, no? So, bakit, no? Ganito lang kasi, no? If your molecule is dipole, that means they will be attracted, no? Mas malakas yung attraction nila. So, since mas malakas yung attraction nila, it would be hard for the molecules to separate, no? Kung kunwari, attached na sila sa isa't isa, mahirap sila paghiwalayin, no? Masyadong emotional, no? For molecules, ganun din. Pag masyado na silang attracted because of them being dipole, that means mahirap na sila paghiwalayin. So, as a consequence, the melting point will increase, no? So, since mahirap sila paghiwalayin, kumbaga kung papakuluan mo yan, maraming heat pa ang kailangan mo i-provide para lang maghiwalay sila, no? Okay, so matatag sila, no? So yun lang yung tendency. Ito, take note nyo na, no? The more tendency for the molecule to be dipole, the higher the chances na tumaas ang melting point, no? So uh, yun yung idea lang dito sa trend na to. Okay, so again, that's for dispersion forces, no? Yung polarizability. The more electrons you have, that means the more tendency for that molecule to be dipole, no? And since that tendency of molecule to be dipole is increased, hence your melting point will also increase, no? Okay, so yun lang naman, no? kunwari, reviewin muna natin to. What types of intermolecular forces exist between each of the two molecule? For HBr, pakita natin yung kanilang mga molecule. Okay, so for HBr, that will be polar. Bakit na? Drawing natin yung HBr. So bromine is more electronegative than hydrogen, di ba? So it will have partial negative charge that will have partial positive charge. So since this is dipole, this is polar, ang kanyang possible na gawin ay dipole-dipole forces na. So yan yung pwede niyang gawin. Okay, so si methane naman, this is non-polar because the bonds are non-polar na. Yung carbon and hydrogen, pag kinuha mo electronegativity difference yan, saan mafo-fall yan? Sa ano? Ang tawag doon? Sa non-polar part na. So, non-polar yung mga bonds niya. So, the molecule is non-polar in general, no? So, what we will have here is that magkakaroon lang tayo ng dispersion forces, no? So, hindi niya kaya gawin yung dipole-dipole. Itong SO2 naman, this is polar molecule because sulfur and oxygen, yung electronegativity difference nila is medyo big, no? So, polar sila, no? Polar yung bond nila. Okay. So, as long as you have a polar bond, that means you have dipole-dipole forces na possible. Pero if your bonds are non-polar, ang pwede lang ay dispersion forces. Okay. So, i-judge natin, sino dito pinakamababa yung melting point, no? Ibig sabihin, sino yung molecules na madali maghiwalay? Okay, ang molecule dito na madali maghiwalay ay methane compared to HBr and SO2. Okay? Bakit, no? Kasi sabi nga natin sa previous slide, no, the more tendency for it to be dipole, the higher the melting point, no. Ibig sabihin mas madali sila mahirap sila maghiwalay, no. Kapag mas mataas ang tendency maging dipole, no. So ganun din dito, no. Since methane is non-polar, it is dispersion lang, meaning nun mababa yung tendency niya na maging dipole, no. So, ibig sabihin nun, madali sila maghiwalay, no? Or mababa ang melting point, no? Okay, so you will see this as gas, no? Makikita mo yan as gas molecules, no? Ang SO2 and HBr, SO2 is gas in general, though it can condense, no? As acid rain. Pwede rin siya maging liquid. Yung HBr, ito liquid talaga yan, no? So, yun lang. So, yun. So, ano yung kailangan nyo lang mapansin na trend dito? Ano yung trend na kailangan mapansin? Increased tendency for dipole, meaning nun, increased melting point, no? Or boiling point, no? So, ano meaning nun? Mahirap sila paghiwalayan, no? Meaning, mahirap paghiwalayan. Paghiwalayan. Okay, so, yun lang yung concept dyan, no? So, yun. So, you check the bonds lang kung anong type ng bond meron sila, no? Kung polar or non-polar. So, kapag polar yung bond, most likely dipole yun. Pag non-polar yung bond, that means most likely dispersion yun, no? So, yung mga dispersion, madali paghiwalayan. Yung dipole, hindi sila madali paghiwalayan, no? Mahirap paghiwalayan. So, mataas kasi ang melting point nila because of the permanent attraction. Okay, so yun lang. Okay. So the last type of intermolecular force is hydrogen bond, no? So hydrogen bond is a special type of dipole-dipole, no? So dipole-dipole din siya, yes. Ano lang yung special sa kanya? This is only observed if you have NH, OH, or FH bonds, no? Okay. So ito lang, dito lang siya nangyayari, no? Sa bonds na 'yan, sa NH, sa OH and FH bond, no? For example, yung water natin ay may OH bond. That OH bond is the hydrogen bond, no? For example, yung ating amino acids, no? Yung amino acids natin may NH bonds doon. So, hydrogen bond din 'yon, no? Yung FH, ito naman yung sa acid, no? So, yung HF bond na yan, meron niyang hydrogen bond. No? So, dito lang sa tatlong bond na to, possible yung hydrogen bond. Kaya sa special, kasi sa kanilang tatlo lang siya, no, observe. No? So, actually, ito rin yung dahilan why life is possible here on Earth. No? So, because of the strong strong characteristic of hydrogen bond, no? So, ibig sabihin, malakas ang dipole ng hydrogen bond, no? So, because of that, no, life on Earth is possible, no? Because imagine kung yung water natin nagbo-boil agad at 20 degrees Celsius, no? Kunwari, nag-boil agad siya at 20 degrees Celsius. Then, there might not be a chance for the primordial soup to exist, no? So, sabi ng mga evolutionary people is that we existed because of the primordial soup, no? Without water, that will not happen. Okay, so and reason why we exist is because of the hydrogen bond of water. Hindi agad siya kumukulo, no? So that's why possible yung primordial soup theory. No? So yun lang, share ko lang. So yun lang yung idea with hydrogen bond. This is the strongest type of dipole. No? Strongest dipole. So ibig sabihin niya mataas ang kanyang melting point, mataas ang kanyang boiling point. No? That's why water doesn't boil agad because of the hydrogen bond. No? So hindi agad siya kumukulo. No? It takes 100 degrees Celsius for it to boil off para kumulo because of the hydrogen bond. Compare that to alcohol. No? So yung alcohol, spray mo yan. Ano nangyayari? 'Di ba nawawala din agad? Naging vapor din agad. Because alcohol is just dipole. Yes, yung dipole, malakas yung kapit nila sa isa't isa. Pero compare that with water, yung water kasi super lakas ng kapit nila sa isa't isa, no? So they will not separate agad, no? So yun. So that means yung water hindi agad siya magbo-boil off compared to alcohol, no? So yung alcohol dipole siya, yes, pero hindi ganoon kalakas yung kapit compared to H bonds, na hydrogen bonds. So yan, magbo-boil off din yung alcohol. Okay, so yun lang yung idea. So ano to? Wala lang. Okay, so yun nga, again, special type yung hydrogen bond because of its high boiling point, no? Okay, so yun lang. Yun lang pinapakita ng graph na yan. Ay, bago tayo pumunta dyan sa liquids, no? So anyway, let's summarize the intermolecular forces, no? In general na, no? Wala bang bakanting slide dito? Okay, so dito na lang. Okay, so let's summarize the intermolecular forces. Ano yung tatlong uri ng intermolecular forces na? Apat pala, no? So we have dipole, dipole. Ano pa meron tayo? Ion dipole. Tapos ano pa? Dispersion. And then we have hydrogen bond, no? Okay, so yan. So ito yung apat na uri ng ating intermolecular forces. Ano meron sa hydrogen bond? Ang bonding diyan ay between atoms of nitrogen and hydrogen, fluorine and hydrogen, pati oxygen and hydrogen. No? So this only exists for OH, NH, and FH bond. No? So dyan lang siya nakikita. No? So yan yung hydrogen bond. So ano meron naman sa dipole-dipole? So dipole-dipole naman, you have dipole molecules. No? So dipole molecules lang yung requirement dyan. Paano uli malalaman kung dipole yung molecules? Tignan nyo yung electronegativity difference, no? So if the electronegativity difference is between 0.4 to 1.8, no? So dipole yan, no? For example, HBr, HCN, no? HCl, no? Ayan. So yan, mga dipole yan. Ion dipole naman, ano yung requirement dito? May ion ka dapat plus may dipole ka, no? This exists sa, let's say, yung water and asin, no? So what happens there is that yung cations and anions of the ions, no? ionic compound, they are being surrounded by the molecules na dipole na. So pinapalibutan sila ng dipole molecules such as shown here na. So ito cation, this is surrounded by the negative end of the water na. So kapag anion naman to, yung hydrogen naman yung dudugtong sa kanila na. Okay? So sa dispersion forces, ano meron dito? You have non-polar molecules here. Non-polar molecules there, no? Lagay natin polar or dipole, no? Para mas familiar kayo sa term. Okay? So ito yung apat na uri ng bond. Then ano yung sabi natin? Sino yung pinakamalakas sa kanilang lahat, no? Sino yung strongest bond? Of course, that would be hydrogen bond, no? So this is the strongest bond, hydrogen bond. Etong dipole, and ion, usually pinagsasama lang yan. No? So this is the second strongest bond. And the third strongest bond, no, or the weakest, is dispersion forces. No? Ang tawag pala sa dispersion forces ay London dispersion forces din. No? O kaya, minsan tawag din dyan ay van der Waals. No? Van der Waals. Siya kasi naka-discover. Okay, so yun lang na. So pagdating sa strength, sino pinakamalakas? Si hydrogen bond. Followed by either of the two. Dipole-dipole or ion-dipole. No? Same lang, rank lang sila. Then lastly, ang weakest ay si dispersion forces. So the stronger the intermolecular forces, intermolecular forces, meaning yan, no? The stronger IMF, hindi yan International Monetary Fund. No? So, the stronger your intermolecular forces, ano meaning nun? Higher boiling point and melting point. No? So, mahirap sila paghiwalayan. So, yun lang yung concept na gusto natin kunin dito. Pag malakas ang intermolecular force, meaning, pag hydrogen bond, yan, malakas yan. Pag dipole-dipole, yan, malakas yan. Pag dispersion, not that much, no? So, the more dipole the molecule becomes, no, the more stronger the intermolecular forces is. That means the boiling point and the melting point is very high, no? So, yeah. Bakit uli high yung melting point and boiling point, no? Imagine that as, eto nga, no? The more attracted ka sa tao, the more mahirap ka lumayo sa kanya, no? Attach ka na, no? So, ganun din dito sa molecules natin. The more dipole they are, the more harder for them to separate out, no? Mahirap sila paghiwalayan, no? So, as a result, mahirap yan kumulo or mahirap yan maging gas, no? Mataas yung kanyang boiling point and melting point, no? So, yun, mahirap silang paghiwa-hiwalayin, no? Okay, so yun lang yung concept dito, no? So the more attracted, that means the more dipole, the higher the boiling point and the melting point, no? So yan, so screenshot nyo na lang yan, no? Or pag sa recording sa YouTube, screenshot nyo na lang din. So ito yung typical trend, no? Okay, so ano gagawin natin, no? So punta tayo dito sa Canvas, dito sa chapter 9, no? Itong PDF na to. May onting activity dito eh. So by the way, ito nilagay ko na dito yung strength, no. Ito na yung mga strength eh. By the way, itong ionic bonds, ionic compounds, next topic yan eh. So ito yung typical strength nila. For London dispersion forces, ito yung mga mga dispersion forces natin, mga non-polar. They have the lowest boiling point and melting point kasi nga hindi sila ganun ka-attracted. So madali sila maghiwalay, no? So when they say attracted, hindi meaning nun crush ng isang molecule yung kabila. Meaning lang nun, wala siyang dipole, no? So yun lang yung concept diyan, no? So, pag sinabi kong hindi attracted, walang dipole. Okay? So, for dispersion forces, hindi ganun ka-attracted yung molecules. So, that's why madali silang maghiwalay or mababa ang kanyang boiling point and melting point na. However, by the time na dumataas ang kanilang attraction, meaning nun nagkakaroon na ng positive and negative charge, nagiging dipole na sila, what happens is that the boiling point and the melting point increases then, no? So, mas lalong attracted sila, so mas mahirap na sila paghiwalayan, no? So, that's why dipole-dipole attractions is the third, no, in the ranking sa boiling point and melting point. Sino yung susunod? Hydrogen bonds, no? Sabi natin ito yung strongest na dipole, no? So, yun. Bakit kaya yung ionic compound yung rank 1? Ang reason kung bakit ang ionic compounds ay ang first in terms of boiling point and melting point is ganito. Temporary yung charge niya, no? I mean, permanent yung charge niya, no? Full positive and full negative kasi yung charges dito. Okay? So, full positive and full negative yung charges dito. Ang sa dipole kasi, partial lang, di ba? So, kumbaga, partial is still weaker than full charge, no? Yung positive and negative ng cation and anion, no? So, yung mga dipole, they are relatively weaker than ionic pa rin, no? So, ionic pa rin ang pinakamalakas compared to dipoles, no? Okay? So, by ranking, paano uli? So, pinakamalakas is yung ionic, no? So, hindi natin siya sinama kanina kasi hindi naman nakalagay yun dun, no? Pero anyway, so, side kwento lang yan. So, focus tayo dito sa tatlo, no? So, for ionics kasi, yun nga, pag full yung charge, siya yung strongest, no? Pero when we are talking about the dipoles lang, ang strongest doon is still the hydrogen bond, no? So, yun lang. So, yan yung ranking dyan, no? So, you can practice on that. Ayan. Ito yung ranking, no? So, H-band, strongest, dipole-dipole, strong, London, weakest, no? So, yan. So, read nyo na lang yung PDF, no? So, ano kaya pwede kunin ditong activity? Okay, so let's try this number 3, no? Try lang, no? A, B, C, D, E. Which of the following can form hydrogen bonds with water? Okay. So, one way to answer that is i-draw mo yung molecule, no? So, i-draw mo yung molecule and tignan mo kung may OH bond dyan, no? So, for example, gawin natin yan. Teka lang. Para blank uli siya. Okay. So, for example, ano meron doon? CH3O, CH3, no? Ganito lang itsura nun. Yung quiz nyo kasi puro drawing din, no? More on concept lang naman. Titignan mo lang yung molecule, no? Kung sino sa kanila pwede makagawa ng hydrogen bond. Ano pa yung isa? Ay, namatay. Magdo-drawing tuloy uli ako. Ay, kalang ah. Ano yan? Ito yung drawing. CH4 yung isa. F- yung isa. Yung isa ay formic acid. At yung isa ay, tawag doon, Na+. Okay, ito yung tanong sa atin doon sa previous question. So sabi niya, sino daw dito ang kaya gumawa ng hydrogen bond, no? Sino sa kanila? So, ang first na gagawin nyo lang is to check kung may OH bond. Ganun lang ka-easy. So, tignan mo kung may O at H na magkadugtong. Hindi porket may oxygen pati may hydrogen pwede ha. No, no. Kailangan yung oxygen and hydrogen magkatabi. So judge natin ito. Can this form hydrogen bond? Hindi. Bakit hindi? Yes, may oxygen and may hydrogen pero hindi sila magkadugtong. Ang requirement magkadugtong sila. May chemical bond between them. So this cannot form the hydrogen bond. So hindi yan pwede mag-hydrogen bond. Ito kaya, syempre hindi. Walang oxygen dyan eh. Ito, hindi rin to. Ion lang yan eh. Itong Na, hindi rin. Ion din yan eh. So ito kaya, yes, ito yung pwede mag-form ng hydrogen bond. No? So asan yung hydrogen bond dyan? Yung OH. No? Okay, so this bond, no, itong OH bond, that is the hydrogen bond, no, and that can form hydrogen bonds with water. So ibig sabihin yan, pwede yan humalo sa tubig, no. For example, yung suka din natin, yung vinegar. Ganito itsura ng vinegar eh. Drawing ko lang. Okay, so bakit tumahalo yung suka sa tubig? Ito kasi may OH din siya, no. So ito yung ating vinegar. Because of the hydrogen bond, it sticks with the water molecules well, no. So yun lang. So yun lang yung kwento ng slide na yun. So ito yung H bonds natin. Okay, H bond. Okay, so ito pa yung isang example, ammonia. Ito yung yung kapag may nahihilo, pinapaamoy ito doon eh. Ewan ko ba. Pero pampagising yung pag may nahilo eh, ammonia. So yun. So this is our ammonia. Pwede rin yung mag-form ng hydrogen bond. Ayun, yung NH na. So yun. So again, paano mo malalaman kung may hydrogen bond? Just check kung may OH na magkadikit, may NH na magkadikit, at may HF na magkadikit na. So, kailangan yung F, may katabi siyang H. Hindi pwedeng F lang siya. Wala tong hydrogen bond. Ito, meron na. So, ganun lang yung pag-inspect, no? Okay, so, one way to check if the molecule exhibits hydrogen bond, tignan mo lang, OH, NH, and FH. Kailangan magkatabi sila. Hindi magkahiwalay. For example, ito. So, hindi ito. Yung magkakadikit lang, na? So, yun. So, yun lang naman. Basta ang kailangan nyo lang i-strengthen na idea dito is this one. No? So, yan. No? Keep in mind ito. Yan lang naman yung important. Eh, no? The more dipole, the higher the boiling point, the melting point. No? Ibig sabihin, the molecules are stronger. Dikit-dikit sila. Okay, so yun lang. Okay, so yun lang. We're done with the intermolecular forces. Now we can proceed with liquids na. So there are two properties of liquids that we can observe. First of which is the surface tension. Teka lang. Ay, ganun. Ba't ayaw niya mag-full screen? Ay, sige, ganyan na nga lang. Okay, so for liquids naman, we have two properties. We have surface tension and yun. Yung isa mamaya is the capillary action. No? Okay, so anyway, punta muna tayo dito sa surface tension. So, viscosity din yung isa mamaya. So, naalala ko lang. So anyway, surface tension, ano to, no? When we say surface tension, this is the capability of water to stretch out, no? So, pag nag-stretch out yung water, surface tension yan, no? So, kailan natin nakikita yung stretching of water? Sa cohesion and adhesion, no? So, for example, ito. Naglagay ka ng tubig sa straw. What you can see is that yung water ay naka-curve siya, no? Pwede ang curve niya nakapataas, pwedeng nakapababa, no? Yung curving of water, that is because of the surface tension, no? So this again, the surface tension is the stretching of liquid molecules, no? Pero bakit kaya sila nag-stretch, no? Number one reason is that they want to be attracted to the other molecule, no? So gusto nila kumabit sa kabilang molecule, no? Kasi same sila ng characteristic. Kunwari, for example, yung water natin, this is polar, yung glass, generally, polar molecule din yung glass, no? So kaya kung makikita nyo sa baso or sa beakers, no, that when you place water sa beaker, magkakaroon yan ng curve pataas, no. Kumbaga yung water ay didikit sa paligid ng glass, no. That's why we have this meniscus, no. Nakapaganon yung water dyan, no. So bakit nakapaganyan yung water instead of flat? Kasi water is attracted to glass, no. Glass is polar. Water is also polar, no. So gusto nila magsama kasi same sila ng properties, no. Okay, so whenever that happens, you have adhesion, no. So you can observe it with the concave meniscus, no. So ano yung concave meniscus? Nakapa U-shape ang meniscus, no. So meaning niyan yung water instead na flat lang, yung nasa edges niya, dumidikit siya kay glass. Bakit siya dumidikit kay glass? Because glass is polar, water is also polar. So match sila, no? Pag nagma-match, magsasama, no? So ganun lang yung idea for adhesion, no? For cohesion naman, ang nangyayari kasi dito, this is usually observed with metals, no? Such as mercury. So mercury and glass, no? So magkaiba sila ng attraction. Bakit? Ang mercury ay metal. So metallic bonds yung meron diyan, no? Metal lang yung meron diyan. Ang glass ay polar, no? So polar to, tas yung mercury ay metal, so magkaiba sila ng forces of attraction, meaning hindi sila matchy-matchy. So kapag hindi sila match, hindi sila magsasama, no? So instead of it curving to the side, no? Ganito kasi kapag similar ang kanilang attraction, pero kapag opposite, pag hindi sila similar ng attraction, no? Not the same attraction, no? When you say hindi similar yung attraction, meaning lang nun yung characteristic ng bonds nila, no? So this is metallic and the glass is polar. Magkaiba yon, no? So kapag hindi sila similar ng attraction, you will have cohesion, no? So ang makikita mo dyan is nagbabulge siya upwards, no? Ang tawag dyan ay convex meniscus, no? Yan. Ito concave meniscus, no? Okay, so ganun lang. Although cohesion is mostly observed with mercury kasi ito lang yung example madalas talaga, no. So metals are not attracted to polar molecules, no. They are also not attracted with non-polar molecules, no. So napaka-choosy nila, no. Since they are not attracted with polar and non-polar molecules, they will not attach to them, no. Hindi siya didikit sa kanila. So pag hindi siya dumikit, it will form this curve, no? This convex meniscus curve, no? So yan. So they are not of the same attraction kasi kaya ganyan. Okay? So yun lang yung idea diyan. Okay? Pero kapag similar sila ng attraction, meaning dipole yan, dipole yung kabila, magsasama sila, no? They will form concave meniscus, no? Okay. So yun lang. So this is actually a technique, no, that you can use in identifying the thermometers you have, no, especially yung liquid thermometers, no. Check nyo yung thermometer nyo. If it forms concave meniscus, meaning nun, safe yon. Water or alcohol lang yun nandun, no. Pero if it forms the convex meniscus, magtaka ka na, baka may mercury yon, no. Kasi before, mercury was used in thermometers, 'di ba? Alam ko naabutan niyo 'yun, no. Pero ngayon, hindi na ginagamit ang mercury, ginagamit na lang yung alcohol, no, as the liquid inside the thermometer. So you can check, no, observe niyo yung thermometer. Kapag naka-curve 'yon pababa, naka-concave meniscus, safe 'yon. Alcohol yung nasa loob. Kasi alcohol is polar, the glass is polar, so they will form adhesion or concave meniscus, no? Pero kapag yan ay mercury, hindi nyo makikita yung ganitong curve. What you will observe is etong convex meniscus. And ito, na-observe ko to personally, no? Kasi dati may glass thermometer kami. Tapos nabasag yun, no? Nakatakot lang. Kasi mercury yun eh. So anyway, na-resolve din naman. Hindi ko na maalala, bata pa ako eh. Okay, so anyway. So yun, makikita mo talaga yung curve, no, sa thermometer ay naka-convex kapag mercury yung nasa loob, no. So that's one way for you to verify kung anong liquid yung nasa loob ng thermometer. Pag metal yon, mercury, naka-convex. Kapag alcohol yon, naka-concave, no. Okay, so yun lang, yun yung kanyang daily life application. So nagagamit to in observing whether there is the same attraction or not, no? And you can infer kung yan ay mercury or hindi, no? So yun yung personal use niyan. Sa medtech, ang ginagawa nyo, for example, kukuha ng dugo, di ba? Minsan gumagamit kayo ng capillary tubes, no? So yung capillary tubes ay gawa sa glass, which is polar. So, ano nangyayari doon, 'di ba? Sa medtech kasi, 'di ba kunwari you have a blood sample. Pag dinikita mo ng capillary tube 'yon, yung blood aakyat siya papunta sa capillary tube, no? Parang ganito yung nangyari. Kunwari ito blood, no? Kunwari ito kulay red yan. Pag dinikit mo itong capillary tube sa blood, didikit yung blood pataas, no? Okay, bakit? Kasi ang blood natin, polar yan because of the water in there, no? Polar yan. And yung glass ay polar din, no? So, magsasama sila, then they will form adhesion, no? Or the concave meniscus. So, yung blood sa capillary. Okay, so ganun lang. So, yun yung mga daily life scenarios when you can see the properties of liquids, no? Adhesion and cohesion. So again, adhesion and cohesion, this is a product of surface tension, no? So ano ba yung surface tension? Yun yung curving of liquids, no? Stretching of liquids, no? So dalawa yung stretching niya, pwedeng concave, pwedeng convex, no? Kapag concave, they have the similar attraction. Pag convex or cohesion, hindi sila parehas ng attraction. Okay? Next one, viscosity. So next, itong viscosity naman, this is called in Tagalog yung lapot, no? Kailan nagiging malapot yung isang substance, no? So one answer there is that if you have strong intermolecular forces, mataas ang viscosity mo, no? Ibig sabihin malapot 'yon. Let's compare water and sugar. So H2O, teka lang, drawing ko yung kanilang itsura mismo. Kunwari, H2O. H, tapos sugar. Compare natin sila, tapos alamin natin kung sino yung malapot, no? So, sugar naman is ganito lang. I don't know this sugar, pero ganyan yung itsura ng sugars natin. Okay, so we have water in here sa taas and we have sugar dito sa baba, no? Sino kaya yung malapot sa dalawa? Okay, so sabi dito sa ating slide, if you have strong intermolecular force, mas mataas ang kanyang viscosity, hence mas malapot siya, no? So, sino kaya sa dalawa yung mas malapot? Paano natin malalaman, no? Alamin muna natin kung anong intermolecular forces ang pwede nila gawin. So, for water, makikita nyo, may O and may H na magkadikit. So, pwede yung hydrogen bond, no? So, this can form hydrogen bonds. Ilang hydrogen bond meron dito? Meron dito isa sa kabila at isa sa kabila, no? May isang OH bond dito sa left, may isang OH bond dito sa right, so it can form 2 H bonds, no? Dalawang hydrogen bonds ang pwede niya gawin. How about sugar? Itong sugar, bilangin natin yung hydrogen bonds niya. So this is 1 OH, this is 2, this is 3, this is 4, and this is 5, no? So may 5 OH bond dyan. Okay. So between the two, sino ay mas malapot? Yung water or yung sugar? So the answer would be the sugar. Bakit yung sugar? Kasi it has more intermolecular force. No? Mas stronger ang H bond dito kaysa sa water. Sa water, dalawa lang eh. Sa sugar, 5. So, ibig sabihin nun, mas marami siyang intermolecular forces kaysa sa water. No? And as a result, no, yan ay malapot, no. So viscous siya, malapot. For example, yung arnibal, no. Pag may taho diyan, 'di ba, arnibal, pag ginanon ni kuyang nagtataho, 'di ba, malapot. Ang sabihin mo, "Ay, kuya, alam mo ba kung bakit ganyan 'yan?" Kasi marami yung hydrogen bonds, no. So ganun, no. So 'yun lang yung idea diyan, no. The more intermolecular forces you have, no, the stronger the intermolecular force is, the more viscous, the more malapot, no. So yan, so you can see here dito sa table yung mga iba't ibang viscosity, though we will not focus on them naman, no. So ang gusto ko lang yung kuning concept is that stronger intermolecular force, no, higher ang viscosity, no. So pag mas maraming intermolecular force, mas malakas yung force, mas mataas ang lapot, no. So yun lang. So ito yung real life application na to, yung arnibal pati yung tubig, no. Yun, no. Ano pa ba? Ito kwento-kwento na lang yan. O ngayon, so tapos na tayo sa intermolecular forces, tapos na tayo sa liquids. Ngayon, punta naman tayo sa solids, no. So yung solids, ano meron sa solids, no? So yung solids kasi, yan ay composed ng atoms na dugtong-dugtong, no. So yan. So may dalawang uri tayo ng solids depending on their characteristic or properties, no. So we can have crystalline solids and amorphous solids, no. So when we say crystalline solids, their ions, no, their atoms are in order, no. Nakaayos yung crystals niya, no. Nakaayos yung orientation ng matter niyo, no. Okay, so may order. When you say amorphous naman, hindi siya order, no. Wala siyang order. Does not possess order. Okay. So as a result, meron tayong solids na matitigas at merong solids na marurupok, no. Okay. So for example, ano yung solid na matigas, no? Yung hindi agad nasisira. For example, yung glass, no? Yung glass sa ating mga devices, sa cellphone nyo, sa computer nyo, kaya sa bahay, yung glass, di ba? Hindi agad yan nababasag. Because in glass particles, no? Yung glass, yung particles doon ay naka-arrange ng maayos, no? There is an order sa mga molecules doon. So crystalline solid yung glass, no? However, ano yung example ng marupok, no? Bukod sa classmate nyo, ano pa ba? For example, yung mga makeup ng babae. So, yung mga baby powder, no? So, solid yun eh. Pero bakit sila marupok, no? Kasi yung crystals doon yung particles doon ay hindi naka-arrange ng maayos, no? So, another example would be yung sa lapis, no? So, lapis mabilis maputol, di ba? Okay, so, hindi kasi maganda yung arrangement ng molecules, no? Okay. Ay, bakit ganyan yung picture? So, hanapan ko kayo ng image ng crystalline solids. So, ganito yung itsura ng mga crystalline solids, no? So, yan, naka-order yung solids nyo, no? So, yan, you have simple cubic, so on so forth. Though, hindi na natin di-discuss yan na masyado nang malalim yan. So, basta yun lang yung idea, no? For crystalline solids, may order, no? So, ano yung order niyan? So, ito yung mga order nila. May arrangement sila, no? However, for amorphous solids, hindi yan naka-arrange, no? So, yun lang yung idea. So, since hindi naka-arrange yung mga molecules, then marupok sila, no? Hindi malakas yung kapit nila sa isa't isa. Pag crystalline, maayos yung pagkakasalansan ng molecules, maayos yung arrangement niya. So, malakas yung kapit nila sa isa't isa. So, ito yung mga iba't ibang uri ng solids natin, crystalline solids. Okay? Mapansin nyo nung naka-pattern pa sila, no? Ayan. So, yan. So, hindi na natin lalaliman yan, ha? Okay. So, yan lang. So yung solids natin, it could be one of the following, no? So yung crystalline solids natin, pwede siyang ionic crystals. Ano meron sa ionic crystals? May ions ka. May cation and may anion, no? So yun. So yun yung mga types of solids. We can have ionic crystals. You have cations and anions there, no? You can also have covalent crystals, meaning nun, wala kang ions, atoms lang, no? Okay, so ano yung difference? Kapag ionic crystals, may ions. Kapag covalent crystals, atoms lang, no? Hindi siya ions. Okay, so comparing the two, no? Yung ating, ba't may animation kasi to? Yung ating ionic crystals, ito ay mas matibay, no? Compared to covalent crystals, no? Okay, so yan. So, ano example ng covalent crystals? Ayan yung diamond, yung graphite, no? Yung nasa lapis, no? So, yan. So, yan. Mga carbon atoms lang yung nakalagay doon. Ano pa? Molecular crystals, no? So, ano yung molecular crystals? Ito yung solids na gawa sa molecules. For example, yung yellow, no? Yung yellow natin, gawa yan sa H2O solids lang, no? Yung H2O molecule na pinagdikit-dikit mo as crystals. Tawag doon ay molecular crystals, no? So, soft lang siya compared to the two, no? Hard kasi yung ionic and then yung no, covalent crystals. Pero yung molecular crystals, they are soft, no, and brittle, no. Okay, so yun lang. Ano pa yung isang type ng crystals? Metallic crystals naman. Okay, so for metallic crystals naman, these are crystals made of metals, no. So yan yung mga aluminum metal, yung iron, no. So yun, gawa sila sa metal atoms, no. So their bonding is called the metallic bonding, no. So wherein the electrons, the valence electrons are just freely flowing around them, no. So yun lang yung idea. And these are the metals that exhibit the metallic bonding, no. So yan. Okay, ito yung summary, no. So for ionic crystals, we have ions. For covalent crystals, we have atoms, no. For molecular crystals, we have molecules, and for metallic crystals, we have metal atoms, na. Okay. So, yan yung mga forces that attracts them together. For ionic, may positive and negative charge. So, meaning nun, may electrostatic attraction. Yung electrostatic attraction, that means positives are attracted to negative, no? For covalent crystals naman, yung mga covalent molecules lang nandun, no? Covalent bonds, no? So, yan. And for molecular, you have molecules, no? May mga molecules ka makikita, no? And yung mga attraction na makikita mo doon ay mga dispersion, dipole-dipole, hydrogen bond. For example, yung yellow, no? So, yung yellow natin, may hydrogen bonds, yung crystals doon, no? Pag namuo siya. And last one, metallic bond. Anong forces meron doon? Metallic bonds, no? So, yan. So comparing the two, comparing all these, sino yung pinakamalakas? The strongest of which will be metallic bond, no? So yan. So this is the strongest type of crystal. Matibay yung mga metals natin, no? Okay, so yan. So this is the strongest type of metals, no? I mean, strongest type of solids, no? Strongest type of crystals, no? So yun lang yung mga gusto nating kunin dyan, no? Again, for amorphous solids, no, yung mga amorphous solids, ito yung mga marurupok, no. Marurupok sila because the molecules are not arranged properly, no. So for example, we have here the crystalline quartz, no. Ito yung ginagamit sa sa mga watches, no, sa Apple Watch, sa Rolex, no. So yan, matitibay yung mga glasses doon, 'di ba? Because the molecules are well arranged, no? So naka-arrange na maayos yung molecules, no? So ibig sabihin nun, mas okay yung kanilang attraction kasi maayos eh. Compared that to non-crystalline glass, no? Yung mga amorphous glass natin, yung mga mabilis masira, no? So mapapansin nyo, walang order, hindi maayos yung molecules. Hence, madali siya sirain. Okay. So yun lang yung idea dyan, no? Ano to? High temperature superconductors. O, last one na tayo. Last one, phase changes. No? So phase changes, ano yung nangyayari lang dito? There is a change of phase ng matter. No? So again, think of phase changes as the separation of molecules. No? If the molecules are being separated, no? Pag pinaghihiwalay mo yung molecules, you will have solids, liquids, or gases. No? And the transition between those spaces are the following. No? You can have sublimation wherein your solid particles will eventually turn into gas. So yung solid bigla na lang magiging gas. Ano example nun? Yung dry ice, no? So yung dry ice, umuusok agad siya, no? Well, meaning nun yung solid nagiging gas agad, no? So carbon dioxide lang kasi nandun sa dry ice, no? So that process is called the sublimation process. Solid to gas, sublimation, no? Then, pag solid to liquid, alam natin that is melting. Pag, ano naman, ano ba yan? Pag liquid to gas, that is evaporation, no? Or vaporization, no? So, yun. Ano pa? Solid to liquid. Nagawa ko na pala. Baliktad pala. Liquid to solid, ang tawag doon ay freezing. Then, gas to liquid ay condensation or condensation. Then, gas to solid is deposition. No? So, anyway, ito lang yung idea. No? So, yun. As you increase the temperature, the molecules will eventually separate, no? So, ibig sabihin maghihiwalay yung mga molecules natin kapag tinaas mo yung temperature. Hence, they will boil off, no? Yung boiling na tinatawag, no? Okay, so yun lang yung idea na pwede natin kunin dito, no? That our matter exists because of the distances of molecules, no? Depending on their intermolecular forces, no? If the intermolecular force is strong, pag malakas yung intermolecular force, they are most likely solid or liquid, no? Pero if the intermolecular force is weak, then gas yun, no? Most likely gas yun, no? So yun ang idea. Ano yung, ano yung gawa naman ng temperature, no? Ano yung silbi niya dyan, no? Ang silbi ng temperature is this one, no? If you increase the temperature of your system, if you increase the temperature of your substance, that means yung molecules mo, pinapagalaw mo, in-excite mo sila, no? For example, we have this solid, kunwari itong dalawang kamay ko, no? So, pag itataas mo yung temperature niyan, if you increase the temperature, what happens is that the molecules get energetic. Gumagalaw-galaw sila. So, as they move, they separate, no? So, yun yung idea kung bakit may temperature doon, no? So, pag mababa yung temperature, magdidikit-dikit sila. However, if you increase the temperature, what will happen is that your particles will get energetic, no? And as they get energetic, they separate, no? So, from solid, magiging liquid yan. Then, pag tinaasan mo pa yung temperature, mas lalo silang maglalayo, magiging gas yan, no? So, yun lang yung idea, no? So, ano yung mga factors that affects the phases of matter? Number one, intermolecular force, no? Stronger intermolecular force, meaning nun, most likely you have a liquid or a solid, no? Pag weak yung intermolecular force mo, most likely you will have gases, no? Then, the temperature also plays a vital role in the phase changes, no? As you increase the temperature, the molecules get energetic, and as they get energetic, they separate, no? Lumalayo sila sa isa't isa, no? So, yun lang yung idea ng phase changes, no? So, ayun yung mga iba't ibang tawag sa phase changes, no? If nakalimutan, you can recall them by just looking at the slide here, no? So, ganun lang yung idea, no? So, ano uli yung reason bakit may iba't iba tayong phases of matter? Meron kasing um, differences when it comes to attraction forces and pwede rin sa temperature, no? Pag mataas masyado yung temperature, maghihiwalay talaga yung molecules doon kasi they get energetic na. Okay. So, yun lang. Ano pa ba yung mga parts dito? We will not discuss the rest in depth, no? Kasi may calculations na yan, no? 'Di ba, bulaga. So, ito mga Gen Chem style nyo, no? By the way, ito na yung last part natin. For the last part of our discussion, we will see the phase diagram, no? So, what is a phase diagram? So, phase diagram is the summary of the conditions kung kailan magiging solid, liquid, or gas ang iyong matter, no? So, ganito ang itsura niyan. On the y-axis, you have pressure. On the x-axis, you have the temperature, no? So makikita mo dyan kung kailan siya magiging solid, kailan siya magiging liquid, and kailan siya magiging water vapor. At certain pressure, there is an equivalent temperature for its boiling point and melting point. No? Okay, so yun lang yung idea dyan. For example, ang solid to liquid transition ng water that happens at 0 degrees Celsius at 1 atmosphere. No? If you increase the temperature further, that means the molecules are getting separated, no? They will eventually become vapor, no? So, yun. So, habang ini-increase mo yung temperature, the molecules become separated to each other and that will cause the water to boil off, no? Maging vapor na siya. Around 100 degrees Celsius and above, no? So, yan. Dito na siya mag-start maging gas, no? Pero if you lower the temperature, that means kapag mababa yung temperature, hindi binabawasan mo yung galaw ng molecule, no? So, pag binabawasan mo yung galaw ng molecule, they will come together to form liquids, then eventually solids, no? So, yun lang yung idea, no? So, yung phase of matter, it's just a matter of, of the distance of the molecules, no? So, they can go here to there, no? So, pwede sila maggalaw-galaw dyan, no? So, yun, depending on the temperature and the pressure, you can have different phases of matter, no? So, yan. So, kunwari, binabaan mo yung temperature mo, nilagay mo yung water sa ref, gaganon lang yan. Pupunta lang yung point sa solid na. Pero kunwari, ininit mo yung yellow, ano mangyari? As you increase the temperature, it will pass to liquid, then eventually magiging water vapor siya. No? So, yun lang yung idea dito. No? So, yung ating matter, it transitions from solid, liquid, and vapor. And the point of transition is usually shown naman dito, no? So given naman yun as given yun sa graph, no? For example, yun nga yun sa water, ang transition ng solid to liquid 0 degrees at 1 atmosphere, liquid to vapor 100 degrees at 1 atmosphere, no? So another example would be carbon dioxide. 'Di ba alam natin with carbon dioxide is that ang transition niya is from solid to vapor, that is sublimation, no? But if you increase the pressure higher, you can see liquid carbon dioxide forming, no? So pwede maging liquid yung carbon dioxide, no? It's just the matter that you have to increase the temperature, no? So hindi ka limited dito sa line na to. So if you increase the pressure, ba't ganito tong mouse? Ay, lobat yung mouse. Kaya pala. So if you increase the pressure, pwede mo makita yung liquid form ng carbon dioxide, no? Pero for practical purposes, such as tayo, nasa 1 atmosphere lang tayo, ito lang yung nakikita natin, solid to vapor, no? Pero kunwari, nasa Jupiter ka, makikita mo yan, may liquid carbon dioxide, no? So, tatlo yung magiging phase transition niya. By the way, may tawag dito sa intersection nila, no? The point of intersection of solid, liquid, and vapor is called the triple point, no? So, ano yung meron sa triple point? At triple point, all the phases exist, no? So, yung solid, magiging liquid, then yung liquid magiging gas, then yung gas magiging solid, no? So, yun, pa-cycle-cycle lang siya doon, no? I don't know if I have a video, no? Pero mamaya pakita ko kung meron. So, yun lang, no? Ayun lang. So, tapos na yung lesson. So, summarize na lang natin yung lesson. Okay, so wrap up tayo para makakain na tayo. So, in summary, tatlo yung kinover natin, no? Actually, apat, no? So, the first one is the intermolecular forces of attraction, liquids, solids, then the phase changes, na. So, apat yung diniscuss natin today. In summary, ano yung mga pwede natin makuhang idea? Sa intermolecular forces, Ano meaning nun, no? So when they say intermolecular forces, these are attraction between molecules, no? So they can be attracted by dipole-dipole forces. Ano meron sa dipole-dipole forces? You have a dipole molecule, another dipole molecule, they will be attracted due to their charges, no? Yung charges nila, dun sila nagkakabit, no? So yun yung idea for dipole-dipole. Ano pa yung isa pang intermolecular force? Ion dipole forces, no? Yung positive magiging attracted sa negative, the negative will be attracted to positive, no? So yan. And another type of intermolecular force is the dispersion forces, no? This exhibits in generally nonpolar molecules lang, nonpolar molecules, no? Bakit, no? Kasi they don't have charges, no? But for them to have charge, there should be a disruption in their electrons, no? So yan, kunwari ito non-polar to, pag may tumabi sa kanyang cation or dipole, there could be dispersion forces, no? Pwede magkaroon ng temporary dipoles. And from the word itself, temporary yan, that means pwede yan agad mawala, no? So, yan. So, this is just temporary. Nawawala din yan, no? And, yun nga, we can say that the dispersion forces is affected by the polarizability, no? So, ano yung polarizability? The more electrons you have, the more chances for it to be induced dipole, no? So, mataas yung chances niya na maging dipole siya, no? Eventually, no? Or, I mean, temporarily, no? Okay, so the more electrons you have, the more polarizable your molecule is, no? So, that means the more ang kanyang characteristic na maging dipole temporarily lang, no? So yun yung trend natin dito kanina. Makikita natin if we have more electrons, mas mataas ang kanilang magiging melting point, no? Kasi yun nga, if you have increased property na maging dipole, that means mas mataas ang iyong melting point and boiling point, no? That's one reason, no? So, yan. So, sinagutan natin yan. Tapos, hydrogen bond. No? So, ano meron sa hydrogen bond? This is a special type of dipole, pero this only can be observed, no, with NH bonds, OH bonds, and FH bonds. So, dyan lang sa tatlong bond lang yan pwede makita. And it should be noted na kailangan yung HI bonded with N, O, and F. Dapat doon siya nakabond. Hindi pwede sa iba. Okay? So, yan. So, special yan kasi that is the strongest dipole. No? Strongest dipole, si hydrogen bond. No? So, yan lang. Then, for liquids, ano yung meron tayo? We have two phenomena for liquid. No? So, surface tension is one of them. Surface tension is the ano tawag na? The stretching of liquid, no? So, the liquid will stretch depending on its neighboring atom, no? So, it can form adhesion, pwede siya dumikit, and as it adheres to the molecules of the other molecule, no? Pag dumikit siya sa kabilang molecule, meaning doon, you can form the concave meniscus, na. So, yun, dumidikit yung molecules ng water sa katabi niya, no? So, yun. Bakit sila dumidikit again? Because of their likeness in the forces of attraction. No? Kapag dipole yung water, tas dipole din yung kabila, you will see adhesion. No? Makikita mo yung concave meniscus. Pero, if yung forces of attraction nila ay magkaiba, you will not see adhesion. You will see cohesion. So, mag-circle yung molecule. No? It will form the convex meniscus. No? Ito pala example niyan. Water and mantika. I-drop nyo yung i-drop nyo yung mantika sa water. You can see blobs of water na nakapa-circle siya. Actually, pag tinignan mo yun sa side view, nakaumbok yung oil, no? Naka-bulge yung oil sa ibabaw ng water because the water and ang oil, hindi sila parehas ng forces of attraction. No? Ang oil kasi ay non-polar, ang water ay polar. So that means they will not adhere to one another, instead they will cohere, no? So ibig sabihin hindi sila magsasama, maghihiwalay sila. So makikita niyo yung blob of water forming, no? May makikita kayong convex meniscus doon. Okay, so yun lang. Another phenomena is the viscosity, no? If you have high forces of attraction, that means you have more viscous material, no? Mas malapot yung liquid nyo, no? Okay? So, yun. The more strong forces of attraction you have, the more viscous your substance is. Ano yung example natin dyan? Yung water and the arnibal, no? Yung sugar na caramelized, no? So, mas malapot yung sugar compared to water because of the hydrogen bonds. No? So, the more hydrogen bonds you have, the more viscous your liquid is. No? So, yun lang. Then, we went to solids na. No? So, ano yung meron tayo sa solids? We have two types of solids. No? We have the crystalline solids. Ano meron sa crystalline solids? Ordered ang structure niya. No? Nakaayos yung kanilang structures. For amorphous solids naman, hindi maayos yung arrangement ng molecules. No? Crystalline solids, these are stronger than amorphous solids. No? Kasi kapag hindi maayos yung arrangement ng molecule, marupok siya. Pag maayos yung arrangement ng molecule, hindi siya marupok. No? Okay, so yun lang yung idea. Examples of crystalline solids would be your quartz, no? The Corning Gorilla Glass sa ating tech devices, no? So yun, mga crystalline solids yun, no? Amorphous solids, ito yung mga marurupok. For example, baby powder, solid yon pero marupok, powder siya, no? Ano pa? Sa mga makeup ng babae, no? So, yun yung mga type of amorphous solids. Even chalk, no? Mapapansin nyo yung chalk, mabilis siya maputol. Amorphous solid kasi yun, no? So, yun lang. Ito yung mga itsura ng crystalline solids natin. So, yan. Appreciate na lang natin. Ang cute, diba? Cute siya, pero mahirap i-solve yan. Ayan, no? May equation pa dyan. So anyway, ano ma-observe nyo sa ating mga crystalline solids? There is an arrangement of molecules na. Maayos yung ayos ng molecules na. However, for amorphous solids, hindi arrange yung molecules nga, no? So these are the types of our crystalline solids, no? So we have ionic crystals. Ano meron sa ionic crystals? From the word itself, you have ions, no? For covalent crystals, you have atoms naman, no? For molecular crystals, you have molecules such as yung ice, no? Ice is just composed of water molecules, no? Then metallic crystals, ano meron diyan? Eh di metals, no? So yun lang yung idea, no? So ito yung summary niya. So you can read them na lang, no? Then for amorphous solid niya again for amorphous solid, hindi maayos yung arrangement ng molecules, hence it is brittle, no? Mas mabilis siya masira compared to crystalline solids, no? Then phase changes, anong sabi lang natin dito? Our matter can transition from one phase to another depending on its intermolecular force and temperature, no? So the weaker the intermolecular force, most likely gas yon. The stronger the intermolecular force, most likely liquid or solid yon, no? Okay. So if you want your solid to be gas, no, pwede yon mangyari, no, by increasing the temperature, no. So as we increase the temperature, what happens is that you are giving the molecules energy for it to move, no? Gagalaw-galaw yung molecules kapag mataas yung temperature. Parang tayo lang yan. Kapag naiinitan, todo paypay, no? So, gumagalaw tayo, no? So, ganun din yung molecules, no? If the temperature gets high, they have enough energy to move, no? As they move, they transition from solid to liquid, then gas eventually, no? So, naghihiwa-hiwalay sila. Yan. Tapos ano pa? Ayan yung mga equation, di na natin pupuntahan yan. Yun lang. Ayun. Last one is the phase diagram pala. So the phase diagram is the summary of the phases of matter, no, at different pressure and temperature, no. Makikita mo diyan kung ano yung itsura ng matter at certain pressure and temperature, no. Para siyang map, no. Kunwari andito ka, makikita mo yung solid yung water. Lumipat ka dito, makikita mo liquid yung matter mo, and then going here, you have a vapor water, no, or gas, no. The intersection of all these phases is called the triple point, no. Actually, may tinatawag pang critical point, no. Somewhere there yon, although putol kasi to, hindi ko makita, no. So when you say critical point, yun yung separation of liquid and vapor naman nila, no. So if you exit the critical point kasi, what will happen is that yung liquid and gas, hindi mo na sila ma-observe, no. Maging unified sila. Whenever your substance is unified, no, I mean yung liquid and vapor phase niya ay naging unified, naging isa na lang yon. Ang tawag doon ay supercritical fluid, no. Although chika lang yun, no. So hindi naman natin gagamitin yun masyado. Okay, so yun lang. Check ko yung video ng alam ko may video ako ng may sinave ata ako dito. Check ko sa ano tawag doon, yung transition nga, no. Alam niya kung ano mga pinapanood ko, orchestra, Among Us, pati yung debate ni Trump, no. May inis ka na lang sa yung mga pinapanood ko. Downloads. Okay. Wala pala dito yung download ko. Ito yung choir pa kami, no? Bata pa ako. So, wala pala dito yung Pero sige, let's check yung tawag doon? Critical point and triple point na. Ito na yung last part, no? Okay, so tignan lang natin yung nangyayari, no? Observe lang natin. Okay, so ganito yung setup, no? If you want to reach the critical point and the triple point, you have to adjust the pressures and the temperature. Teka lang. I don't know if naka-share yung audio, pero share ko yung audio, ha? Kita niyo yung mukha ko. Wait lang. Ayan. Okay. Sige, manood muna
Existing
tayo.
as a solid, a liquid and a gas, all at the same time. Sounds impossible, doesn't it? It's what's known as the triple point, and we are going to demonstrate it now. Any pure substance can exist in three phases. It can be a solid, a liquid, or a gas. We can show these phases using a pressure-temperature diagram called a PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. There's a melting line between the solid and the liquid phase, the sublimation line between the solid and the gaseous phase, and the vaporization line between the liquid and the gaseous phase. The triple point is the location where all of these lines meet. It is specified by a certain pressure and temperature that is characteristic for each substance. If a pure substance is at these specified temperature and pressure values, all three phases will be present at the same time. One says that the three phases coexist. Pure water has a triple point temperature of 0.01 degrees Celsius and a triple point pressure of 611.5 Pascal. This is the same as about 0.6% of the usual atmospheric pressure. At this point, water will exist both as ice, as liquid, and as vapor.
So ano sabi niya, no? So when you have triple point, no, makikita mo yung three phases of matter all in one, no? Para siyang trinity, no? So three persona, isang itsura na.
See what this looks like in practice. For this experiment, we need a vacuum chamber which is connected to a vacuum pump. A combined pressure and temperature sensor is connected to the hose between chamber and pump. It is also connected to a PC via USB, and values of absolute pressure and temperature in degrees Celsius can be shown on the screen. Inside the chamber, we place a Petri dish with liquid water. After the chamber has been sealed, the pump is switched on. Both pressure and temperature start decreasing immediately. During evacuation, the liquid water starts to boil as the pressure drops to the saturation pressure at the given temperature. The glass beads reduce the splashing of water during boiling while the pressure decreases. They will also provide nucleation sites for the other two phases. While the pressure drops quite quickly, it takes longer for the temperature to approach values around 0.01 degrees Celsius. Unfortunately, our pressure sensor cannot measure below 1.2 kilopascal, but we will see later that the pressure is low enough as the water will be in all three phases. This can, however, take a few minutes. After some time, we see both formation of ice on the surface of the liquid water and that vapor bubbles appear in the liquid. We now have a situation where the water is boiling under a thick layer of ice. This is water at its triple point. All three phases coexist. The different phases are, however, not in equilibrium, as the amount of water in each of the phases changes with time.
Okay, so yun yung triple point na makikita nyo may solid, yung ice, tapos may liquid dun sa gilid, tapos may bumubula, may gas na. So all the phases exist, no? So that's the visual observation pag may triple point na. So lahat sila nag-exist na. So in achieving the triple points, you have a special setup dapat in order to decrease the pressure and the temperature. So you will have this setup na. So ngayon naman sa critical point naman tayo, no. Okay, so critical point again, this is the point wherein the liquids and the gases are last separated, no? So anything beyond that, hindi mo na makikita yung difference between liquids and gases, no? So panoorin na lang natin.
Every substance has a critical temperature and a critical pressure. When a substance is subjected to temperature and pressure that both exceed these critical values, it enters what is called a supercritical state. Any pure substance can exist in three phases. Can be a solid, a liquid, or gas. We can show these phases using a temperature-pressure diagram called the PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. We have the sublimation line, which divides the solid and the vapor phase. The sublimation line ends at the triple point, which is the point where all three phases coexist. There is a melting line between the solid and the liquid phase, and the vaporization line between the liquid and the gaseous phase. The vaporization line ends in the critical point. The temperature on this point is called the critical temperature and usually gets designated the symbol TCR. The critical pressure has the symbol PCR. These values, together with the critical density, are characteristic for each substance. With pressure and temperature that exceed the critical values, the substance will become supercritical and the differences between the liquid and the gas phase disappear. Let's see how this works.
So again, so sabi niya, no, kapag lumagpas ka na ng critical point, you will no longer see the difference between liquids and gases, no. So yun. So kumbaga yung critical point, yun yung last point, no, na makikita mo silang magkahiwalay. Kasi beyond that, magsasama sila as a whole, no.
In
So,
practice.
tignan natin.
For this experiment, we made our own pressure tank. It has a thermometer, a pressure meter, and a pressure relief valve. We also have some dry ice, which is carbon dioxide in the solid phase,
Ayan,
a heating plate, and a heating base. You put some dry ice into the tank and seal the tank. As the pressure tank is completely sealed, the pressure builds. The dry ice starts at a low temperature, but with the rising pressure, it soon turns into a saturated liquid vapor mixture at about 40 bar and 5 degrees Celsius. By applying heat to the tank, we increase the pressure and temperature towards the critical point at constant volume.
Okay.
CO2 has a critical temperature of 31.25 degrees Celsius and a critical absolute pressure of 73.9 bar.
So what you can see here is that makikita
So we
nyo
want to
yung-
heat
ay,
up the carbon dioxide to its critical
Ba't may YouTube try?
temperature, and because the volume of the tank is constant, we can also build up the pressure. As the pressure and temperature reach the critical point, the distinction between the liquid and gaseous carbon dioxide becomes less visible and eventually disappears.
So yan, so nangyayari na yung triple point, no? So kanina nakikita nyo yung separation ng liquid and gas.
The
Ngayon,
phase
wala
boundary between the liquid and the gas vanishes.
na. Balikan
The
natin.
pressure and temperature reach the critical point.
So dito, nakikita nyo pa yung separation. Ito yung liquid, ito yung gas. Then, pag na-reach na niya yung supercritical point, meaning lumagpas na siya doon,
Its
tignan nyo yung
critical
nangyayari.
temperature. And because the volume of the tank is constant, we can also build up the pressure. As the pressure and temperature reach the critical point, the distinction between the liquid and gaseous carbon dioxide becomes less visible and eventually disappears.
Okay, so yan. Hindi mo na alam kung sino yung gas, sino yung liquid, di ba?
The phase boundary between the liquid and the gas vanishes.
Okay, so yan lang naman yung kwento dyan, no? Ay, hindi. Hindi ikaw, Siri. So, yun lang yung kwento natin dyan, no? About the phases of matter, no? So, again, bakit uli may different phases of matter? Because of the distances of molecules, no? If they are far enough, they will have gas. Pag magkakadikit, solids, no? So, anything in between is just a matter of intermolecular force and temperatures, no? And pressure as well. So with that, no, so we're done with chapter 5, no. Next meeting, ano gagawin natin? Next meeting will be a consultation week, no. So hindi required lahat umattend ng synchronous. So if you have any questions, raise them to me, no. So yun. You can now answer the quizzes, no, and all of it will be due on October 11. A day before your examination. So you can take them na, no? So yun, may mga naka-perfect agad. Yung mga unang nagpasa, mataas yung score. Eh. So hopefully lahat, no? So yun lang. So I will see you again next meeting, no? And the recording of this class will be uploaded on YouTube, no? So yun lang. So thank you very much for attending, no? Medyo na-consume natin yung entire discussion time, no? Pero okay na tayo. Yun lang naman yung coverage na gusto natin sakupin, no? So, next meeting, consultation tayo kung ano yung mga kailangan nyo pa tanungin, no? So, okay lang, no? So, yan. So, most likely, message nyo na, no? Then, we will have the synchronous explanation, no? So, yan. Anyway, not everyone is, hindi naman required tayo umattend, no? So, ayun. So, yung mga may tanong lang, sige, tanong kaya na. So, yun lang. And thank you for your participation today. Okay? So, with that, tapos na po yung class natin. Okay, so sige. By the way, i-download nyo na lang yung mga files, ha. Andito sila sa Canvas, no? So, ako, personally, I will prefer you to download the PDF, no? Download nyo na lang tong PDF. Andun na lahat ng lesson, no? Although you can open all these PowerPoints then para may additional materials kayo. Okay? So yun lang and thank you for your attendance today. I'll see you again.